All right, let's do a review of forces and Newton's laws. This is not a full lecture, and I'm not going to reteach everything from scratch. In this review, we'll go through the core ideas you actually use, what forces are, how free body diagrams work, Newton's three laws, and how forces connect to motion. I will also point out the most common mistakes students make with force problems and show you how to fix them. At the end, I will give you a simple way to study this topic so force problems stop feeling random. A force is a push or a pull that can change an object's motion. Forces are vectors, which means they have size and direction. Multiple forces can act on the same object at the same time. What matters is not each force by itself, but the combined effect of all forces acting on the object. A free body diagram is a picture that shows all the forces acting on one object, only one object. You do not draw forces that the object applies to something else. You only draw forces acting on the object you are analyzing. Every force starts on the object and points outward in the direction that is correct for that force. A clean free body diagram is the most important step in any force problem. Newton's first law says that if the net force on an object is zero, the object doesn't change its motion. That means an object is at rest and stays at rest, and an object that's in motion keeps moving at constant velocity. If motion is not changing, the forces mass balance. This law is about equilibrium, not about motion starting. Newton's second law connects force and motion. It says that the net force on an object equals mass times acceleration. This law explains why motion changes. Acceleration points always in the same direction as the net force. Individual forces do not cause acceleration by themselves. Only the net force does. Newton's third law says that forces come in pairs. If object A pushes on object B pushes back on object A with the same size force in the opposite direction. These forces act on different objects, so they do not cancel each other in a free body diagram. This law is often misunderstood because the forces look equal but affect different objects. Some forces appear over and over. Gravity pulls objects downward. Normal force is the support force from a surface. Tension is the pulling force from a rope or a cable. Friction resists motion or attempted motion because surfaces in contact. Each force has a specific direction and a specific cause. Naming forces correctly helps prevent mistakes later. Here's what matters most in force problems. Always start with a free body diagram. Choose a coordinate system before writing equations. Separate forces into components if needed. Write Newton's second law in each direction separately. If acceleration is zero, the forces mass balance in that direction. One common mistake is drawing too many forces or missing forces in the free body diagram. The fix is to focus on one object and ask what is actually touching or pulling this object. Another mistake is thinking balanced forces means no motion. The fix is to remember that balanced force means no change in motion. A third mistake is canceling action-reaction pairs in the same diagram. The fix is to remember that Newton's third law of forces act on different objects. To study forces, practice drawing free body diagrams without solving the problem. Check whether forces balance in each direction. Practice writing Newton's second law before plugging in numbers. Redo problems where diagrams were unclear. Force problems get easier when diagrams and directions are clean.